Okay, well, if you look at what we've accomplished here so far, we're basically done with what would be the first 2 nights of class, okay? That's broken up into 16 or 17 videos, I think it is, right? I got to remember where we stand. I know I had kind of an introductory video, but then I think there were 16 videos of lecture. Yeah, 16 lecture videos, plus that introductory video. So, alright, well, we're trucking right along. We're going to start in now on night 3, linear equations. Okay, we're going to finally start solving equations, and we use that for a whole host of things, okay? So let's get cracking here. Alright, linear equations of one variable, okay, to be a little more specific on what we're doing. Okay, one variable for now. Okay, just x, or we'll switch to y or some other letter, but just one variable. And now that word linear refers to the exponent on our variable x. Okay, we're going to have this form. Now we have all kinds of alphabet soup there, but the a, b, and c will be known numbers, and the x is the only unknown. Okay, so really only one variable. And that word linear, you know, we'll look at a little bit at, well, we won't look at too much at graphing, but if I were to graph a linear equation of 2 variables, it graphs into a straight line, okay? But more mathematically speaking, what that word linear is talking about, it's talking about the variable, the exponent on my variable x. When no exponent's shown, there's an exponent of 1 there, okay? So some ax to the first power plus b equals c. The minute I have an x squared or an x to the third power or some other x, it's no longer linear and things become more complicated, okay? So all the equations we're going to look at is going to be of the form of x to the first power, okay? Now, equations are just 2 expressions set equal to one another, okay? If I ask you, x plus 3, if I give you that, that's an expression. And the only thing you can do with an expression is simplify an expression, which that's already simplified, or you can evaluate an expression, turn it into a value, but I have to give you a value of x to do that, right? I have to say, hey, x equals 5. And once I say, hey, x equals 5, now you can say, okay, the value of that expression is an 8. Okay? But I gave you the x equals 5 in the expression. Equations are different. Equations have equal signs. Okay? That equal sign says, hey, there's a balance at work here. Think of the old balance scales, right? I put 10 pounds of stuff on one side of the balance scale. I got to put 10 pounds of stuff on the other side of the balance scale in order for it to be balanced, right? And that's what an equal sign is. It's a balance between 2 sides. Both sides of this equal sign have 10 pounds of stuff on it. It's just that this side doesn't quite look like a 10. It looks like an x plus 3. But it's really a 10 because the other side says it's really a 10. Okay? X is holding the place of some number. Some unknown magical mystery number I call x, plus 3 more gives me 10 altogether. Okay, now we don't need to know any algebra to know that it's got to be a 7, right? Because only 7 plus 3 equals 10. There's no other number out there that if I take that number and I add 3 to it, I'm going to get 10 for the answer, right? So x equals 7. Okay, we found it just kind of common sense wise. We didn't really do any math or algebra to find it, okay? But that's always going to be my goal. Take whatever I'm handed and turn it into x equals some number, and then that number is the answer. Okay, so let's examine this a little bit more. X plus 3 equals 10. I want to take this, and I want to get all the way down here on the paper and just have x equals some number. Oops, you can't see what I'm doing. X equals some number, and then that's my answer, right? If my goal here is to find x equal number, would you agree that if I had x plus 0 equals number, I mean, that's just as good as x equals number, right? Because plus 0 is not hurting anything, right? So if I had x plus 0 equals number, I'd be just as good as x equal number. And if you look what I've got here, I'm close. I got x plus 3 equals number. Okay, I just need to have x plus 0 equals number and I'm done. So I need to magically turn my 3 into a 0. Okay, and the way we're going to do that is by adding, subtracting, multiplying, or dividing numbers on each side of this equation. Okay, let me do a quick sidebar. No one's going to argue with me that 5 equals 5, right? We'll call it an equation. It's got an equal sign. It's a balance. You're not going to argue with me, right? If I say 5 plus 4 equals 5, now you do have a problem with that, right? Because that's not equal anymore. But if I go ahead and add 4 over here, now you should be happy again. It's 9 equals 9. It's not 5 equals 5 anymore, but it's equal, right? And that's the key. What about 5 minus 2? You say no problem as long as I make it the same on both sides. What about 5 times 6? No problem as long as I'm consistent. I can take my starting point. I can add number to both sides. I could subtract a number from both sides. I could multiply a number of both sides. I could divide both sides by 3. No problem. As long as I do the exact same thing on both sides, they're still equal, right? It's a perfect balance. Well, I'm going to do the same thing over here. It just doesn't look like a perfect balance, but it is because the equal sign says it is. So on this over here on my real problem now, I'm going to just decide, just like I just decided over here, I'm going to decide to subtract 3 from both sides. So I'm going to just show that, minus 3 on both sides. Okay, well now look what happens. Now I've got x. The plus 3 minus 3 goes to 0, so I've got x plus 0 equals whatever 10 minus 3 is, some number, and look at that. I got x plus 0 equals number. Okay, now we won't show the plus 0. We'll just say x equals number, and what do you know, we got our answer. We solved this equation. We didn't just kind of luck into it the way we did earlier. We actually went through the techniques to solve it. Okay, because we remembered that it's a balance, and we added, subtracted, multiplied, or divided both sides of that balance in order to get x all by itself equals number. And that's our goal. Okay, now it's got to be 1x equals number. And we know that x and 1x are the exact same thing, so we had it, but we're not always going to be so fortunate to have that 1x every time. This time we were. Okay? All right, sweet. So x plus 3 equals 10, we were able to solve it. Okay? What about this one? What about x minus 3 equals 8? What about that one? I want x equals number, but I've got a minus 3 in the way. Before I had a plus 3 in the way. Well, now I've got a minus 3 in the way. It's an obstacle for me. I got to clear it out of there. I'm going to turn that minus 3 into a 0 by adding 3 to both sides. So now again, I'll write the plus 0 just one more time. X plus 0 equals 11, which means x equals 11. Okay? We're eliminating obstacles that are preventing us from having this balance. Okay, maybe we switch to a y, no problem. We could have some goofball decimal or fraction thrown in there. We're not going to let that stop us. X plus 1.4, y plus 1.4 equals 2.06. I got to get that 1.4 out of there. I'm going to subtract it away from both sides. Now I've got y all by itself with an equal sign next to it. I just have to crunch the numbers of 2.06 minus 1.4, and I'll get 0.66 when I do that. Okay? All good. Alright, so far so good. Should we throw a fraction in there? I think we better. Why not? I'm going to trick it up in 3 ways. I'm going to throw some negatives in there. I'm going to put x on the other side of the equal sign, and I'm going to have a fractional problem. I mean, we got whammies galore here. We got to tackle this. if my goal is x equal number, right? That's my goal. It's just as good if I have number equals x with x on the other side. So I'm going to leave the x over there. That's not a problem. But this fraction business is a problem. Okay, now we are going to learn a little bit better way to handle a fraction problem a little bit later. But right now we're just going to tough it out. I'm going to get rid of this minus 2/3 by adding 2/3 to both sides. Okay, so it goes away over there on the right. Okay, pardon me for a second. Okay, but over here on the left, I got to deal with it now. I got to say, okay, I got negative 1/2 plus 2/3. That's what x equals. Okay, I got to simplify that. Common denominator and all that. And now we did learn a little fraction technique. Your calculator ought to be able to handle this. Okay, so let's bust out a calculator example. Again, your negative situation is different. But I'm going to say negative 1 fraction button half plus 2 fraction button thirds equals, I'm going to get a positive 1/6. Done. Okay, and that is correct. Alright? Now, sometimes we need to do a little simplifying and cleaning up before we actually solve. What about this one? 5y plus 3 minus 4y minus 8 equals 6 plus 9. Okay? We got to clean up some stuff over here on the left and the right before I actually start solving. So now don't get confused. Now I'm just combining like terms. I got a positive 5y and a minus 4y. Combine like terms, that gives me a 1y or just a y. I've got a 3 and a minus 8, so that gives me minus 5. Okay? Combining like terms. Same thing over here. Combining like terms gives me a 15. Okay? Now I'm to the point where I'm solving. I want y all by itself. I got this minus 5 in the way, so I'm going to add 5 to both sides. And I'm just crossing it out here, but what is it doing? It's turning into a 0. Negative 5 and plus 5 turns into a 0. So I've got the 1y equals whatever this is over here, in this case 20. You don't have to show the y. Y equals 20. Okay? All good there? Okay. Let's take a gander at our next example. What if I have x's on both sides? For example, 4x equals 7 plus 3x. Okay? Well, I only want x on one side, and I want my constants to be on the other side. Okay, so I really need to get this 3x away. And I want it over there on the other side, and I want the 7 to be alone over there. Okay, so I'm just going to use the same kind of algebra skills. It's a balance. I want to make 3x disappear over here, so I'm going to subtract it away. Whatever I do on one side, I have to do on the other side. Okay, 4x minus 3x gives me 1x, or just x, equals 7. 3x minus 3x, that's 0, so I don't have to do anything more, and actually I'm done. I got x equals 7 already. Done. Remember, our goal is to always find x equals the number, and I just found it. Okay? What about this next one? 3y minus 9 equals 2y plus 6. Okay? We're going to get to the point where I say, it doesn't matter if you put the y's on the left and the constants on the right, or vice versa. You can put the y's on the right and the constants on the left. It ultimately doesn't matter, but we need to learn one more trick before we can have the complete freedom to do that. So let's put our y's on the left, okay, for now. And generally speaking, we'll do that anyway, but let's put the y's on the left. So I want to make 2y disappear, so I'm going to subtract it. 2y minus 2y is 0. It's gone, just like magic. But I have to keep the balance, so I'm going to do the same thing on that side. 3y minus 2y is 1y. So I've got 1y minus 9 equals 6. Okay? Now I want to make the minus 9 disappear. Just like magic, I'm going to add 9. Minus 9 plus 9, goodbye. Gone. Copycat myself over here. Y equals 15. That's how we solve these problems. We get all the obstacles out of the way of having our variable all by itself equals some number on the other side, and then that number is the answer. Okay? It has to be 1y or 1x, and all our problems have always worked out that way, that we always at the end had 1y or 1x, but we're not always going to be so lucky. Okay? For example, what if I have 2x equals 10? Okay? I need x equal number. I need 1x equals number, but I don't have that. I've got 2x equals number. Okay, so I've got a little problem here. I'm in a situation here. I've got to do something about it. How am I going to turn that 2x into a 1x? Okay, now sometimes students say, well, you got to subtract 2 from both sides, because we've kind of been doing that. So we say, well, we got a minus 2 from both sides. Okay, well, that's not going to work, because these are not like terms. So it's going to be 2x minus 2 over here equals 8, and that looks worse, right, than what we started with. So they're not like terms. So if somebody says that, you know, we talk about why that's not going to work. And then somebody says, oh, okay, I got it. Well, how about if we subtract 1x then from both sides? Because then 2x minus 1x, that gives me 1x, and that's what I want. So that looks good on the left, but look what we have over here on the right. Those aren't like terms. So now I've got an x over there that I don't want. Okay, so that's really not a good way to go either. So this is 2 times x equals 10. So what if I divide it by 2? Because 2 divided by 2 gives me a 1. So that's just going to be a 1x over here on the left when I do that. So I got to divide by 2, again on both sides. 10 divided by 2 is 5, 1x equals 5, x equal number, that's what I want. Okay? So I'm going to ultimately divide by that coefficient in front of x when I run into this case. Okay? What if it's a fractional kind of thing, like x divided by 5 equals 9? Okay, now what am I going to do? Well, another way to think of this, x divided by 5, is to call it 1/5 x. Okay, let me do a sidebar here. X over 5 is identical to 1/5 x. It's just 2 slightly different ways to convey the same thing. Okay, when we have a fractional coefficient, we can put the x up in the numerator, or we can put kind of the fraction in front of the x. Okay, what we cannot do is somehow put, you know, the x down here with the 5. That's not the same. It either goes in the numerator or it kind of goes next to the fraction itself. But it's in the numerator. You know, I could sneak a denominator of 1 there, so just to be clear. It's in the numerator. It's not in the denominator. Okay, so when it was written here as x over 5, I could call it 1/5 x. Okay? And we could say, well, let's divide away that number in front of x, right? So divide both sides by 1/5. But boy, that looks clunky, doesn't it? That looks really weird. Divide both sides by 1/5. So if I go over here and I take 1/5 divided by 1/5, remember our rules of fraction says, well, that's really 1/5 times the old flip-flop, 5 over 1 equals 5 over 5 equals 1. So when we have a fractional coefficient like that, let me just rewrite it. Instead of dividing by 1/5, let's just times by 5 over 1. That'll be easier. Times by 5 over 1 over here. So that turns into just x. Okay, this is not necessary to have a denominator over here because it's 1. 9 times 5 is 45. X equals 45. Okay? So that's how we can tackle a problem like that with a fractional coefficient. We'll multiply through by the reciprocal of that fraction. Okay? Otherwise, we're going to divide through by the coefficient in front of x. Now, let's run through a couple of those. A couple more. 6x equals 30. I want 1x. Divide by 6, divide by 6. That gave me the 1x equals 5. Doesn't matter what that coefficient is. It could be a negative number. Negative 7y equals 56. I want a positive 1y, not a negative 7y. So I've got to divide both sides by negative 7. And in this case, I get y equals negative 8. Okay? Could be some goofball decimal. Negative 18.9 equals 3. Let's switch to a z this time. Put it on the right. Divide by 3. Divide by 3. Z equals negative 6.3. Okay? Divide by that coefficient in front of x. Okay? If it's a fractional coefficient, I'll multiply through by the reciprocal. 3/4 y equals 12. I'm going to multiply by 4/3. Multiply by 4/3. That just becomes 12 over 12y, right? I mean, I guess I could write it. 12 over 12 times y equals, what's that going to be? 48 over 3. Okay, well, 12 over 12, that's just a 1y, or just a y, and 48 over 3 actually divides away nicely into a 16. Okay? All good, all good, all good. What about a coefficient of negative 1? Okay, we got to watch out for this. Negative x equals 8. This is like the biggest no-brainer equation in the world. I want to know what x is, and I'm told what negative x is. Well, it's just the opposite. If negative x is 8, then x has to be negative 8. Okay, but for some reason it trips students up. So the easiest way out is put a 1 in there. Negative 1x equals 8, and then just divide away the negative 1 like you would any other coefficient. X equals 8 divided by negative 1, which is negative 8. Okay, that's kind of the easy way out of that one. What about negative 8 equals negative 5? Same thing. Call it negative 1x equals negative 5. Divide that negative 1 away. Negative divided by negative gives me a positive 5 in that case. Okay? Alright, good deal. Alright, so we're going to trick it up. The next video is just going to keep tricking these equations up and make them a little more and more and more clunky and complicated, which means we're going to simplify them a little bit more before we actually start solving.